Hi, my name is Antonin Danallet, and in the next few minutes I'm going to present our article about location choice using longitudinal Wi-Fi data. In this article, we provide a dynamic model for location choice adapted to data collected over a long period of time. This model corrects for endogeneity. We apply the model to the choice of a catering location using Wi-Fi traces, and we show that it improves the predictive power compared to a static model. We present cross-validation, price elasticity, and we predict market shares in the case of the opening of a new catering location. Destination choice models are important in order to understand travel behavior. They are useful for planning future infrastructures and evaluating future policies. Nowadays, these models are increasingly reliant on data from new technologies, such as data from Wi-Fi access points. These data are fundamentally panel data. Data are collected over several days, weeks, or months. Location choice models must be adapted to this data. Let's take the example of the choice of restaurants to illustrate our method. The choice of a restaurant at time t depends on observable characteristics, such as cost or distance. It also depends on unobserved characteristics, such as the quality of service. With panel data, we assume a state dependence. The choice at time t depends on the choice at time t-1. Here we have a problem. Unobserved time-invariant components associated with the decision maker, such as a preference for healthy food, generate serial correlation between the decisions at time t-1 and at time t. As a consequence, the choice at time t-1 and the unobserved factors at time t are correlated since they both depend on the preference for healthy food. This is called endogeneity. It has to be taken into account to avoid bias in the estimation of the parameters of the model, and we use a correction method introduced by Wooldridge. In a case study on a campus, we use actual Wi-Fi traces. We observe that students and employees tend to visit restaurants that are closer, cheaper, having large capacities, and that offer beer. What would happen if we increase the cost of a menu by 1%? What proportion of visitors would we lose? Here, we compare the static model and the model we propose, a dynamic model with agent effect correction. First, we observe that students are more sensitive to price than employees. Second, if we don't consider the panel nature of the data, we underestimate the number of clients we would lose by increasing the cost. We also forecast the number of visitors for a new restaurant that had not yet opened when we collected the Wi-Fi data. This figure shows that by using a static model and ignoring the panel nature of the data, we would overestimate the number of visitors in the new restaurant. For more explanations about theta and the different values and colors, please check our paper. We conclude that Wi-Fi traces allow for the understanding of pedestrian destination choices. It also shows that, when collecting longitudinal data from cell towers, GPS or Wi-Fi, destination choice models must account for endogeneity. Note that the models and data are available as supplementary material.